Hello. Yeah, this is the assignment 3 from Human Factors in AI, and this is from a product management specialization course. And for this assignment, I had taken the problem statement, which I had already considered for my second chapter assignment 2. So let us read the assignment. So the problem statement here is the air pollution is actually getting increased day by day in a country like India. Where do we need a protective cap for our respiratory systems while traveling in a passenger car or car around the air polluted regions? So during traveling, the passengers sitting inside the car mostly they will be getting affected by air pollution factors like dust or smoke in air. So when during the glass windows of the car are getting open during the driving state. So this is a problem statement I had selected and I had given a solution with our AA product. Let us go for the next slide. So here if you see now under the task analysis, so the problem is again the human respiratory system is mostly will be getting affected by the air pollution factors when any of the car side door glass windows are open during the driving condition. Why it matters is when you are getting exposed to these air pollution content for a long time. So surely it will your respiratory organs like lungs will be getting affected very severely, and our current state of safety mechanism is we need to close all the doors manually, and we don't have any automatic operation for the same. And with the help of our AI product, we have a solution with our small logic. Let me explain in the next slide. So the task analysis here is our main objective is yeah we need to protect our human respiratory system from air pollution, and the trigger is the warning of severe air pollution in environment or outside the vehicle. So this trigger will happen when we are driving a car in a peak time during morning time when we are going to an office or to a school time. So during those conditions, the air pollution content will be very severe. So the action, what is this? Our ECU, basically it will be connected to some two external sensors, dust and smoke, and those sensors will be sending the raw values to our ECU during the runtime, and our ECU will be receiving it at all the time. So what happens is it will be checking for the threshold values. It's nothing but when the threshold is reached, our pollution content is more than the expected. And the decision is what we're going to take is the pollution alert signal generation. This is nothing but the output of our ECU. When this signal is set, all the windows of our car will be closed if it is open, and the AC also will be turned on if it is not turned on earlier. So this is the task flow. So in our task, our user is nothing but the other ECUs in the vehicle network. So our ECUs is nothing but the AI product which is actually connected to the vehicle network, and other ECUs are basically the other users which are actually receiving the data from this our particular product, our AI ECU. The main task is we need to transfer this particular signal, pollution alert signal, to the respective ECU for the further analysis. And here under the user experience design, so considering the input and output, so our product basically they will be receiving messages from other ECUs in our network for like states like wake up, on, and sleep, and our ECU will be transferring the output messages to other ECUs in the network for considering the safe reaction. Considering the transparency in this use case, actually we don't need of using the transparency in our design model because it is a ECU which will be, it is not like a software which you're using in a mobile. It's nothing but the ECU which will be available in the car, in the engine department. So we don't need any transparency. On communicating uncertainty, yes, our ECU during the error condition, I mean during the severe air pollution condition, so we are actually sending this pollution alert signal generations will be transferred to the respective ECU for further analysis. So here there will not be any possibility of uncertainty here. In the feedback loop, actually again in this use case we don't need this design. Considering the privacy consideration, yeah, the data privacy laws what we have currently in the US as well as Europe, so they are not applicable to this particular vehicle ECU network data, especially in a car, because these data are very specific to OEM, and it will be these data are very private to a particular OEM, and it will not be shared to any other OEM. So there is not any universal laws to protect the same. It will be a safety. I mean those requirements are very specific to particular OEM. Considering the ethical values, the biases are not possible here in this ECU network data because all will be predefined during the recommend analysis phases itself, and the development and testing also. So there will not be any data modification during the runtime, and so the data framework is ready and it will not be modified at any time at any cost. So considering the goals of ethical AI, the fairness, yes, our software logic behavior will be as per customer requirements, and our ECU will be doing the same behavior all the time, and so the fairness is met. Considering the accountability, the product, this particular AI product will be owned by the OEM or any supplier who were actually developed this product, tested and deployed. And in so the accountability is also met. In transparency, yes, the software quality will be met during the final product release from OEM. So when the software is getting deployed to the particular product, so our transparency is also completely met now. Yes, so thank you.